is that the nanoparticle albumin extravasates or leaks out of blood vessels in tumor blood vessels much more efficiently than it does in normal blood vessels because of the leakiness of tumor blood vessels. So this is the albumin that encapsulates the Taxol. Taxol's in the center of it. And it has these projections that can be targeted. Now, Abraxane is not targeted. It's just encapsulation of Taxol. And what we're taking an advantage of is the enhanced permeability that we see in tumor microvasculature. And that's shown here on this electron micrograph. This is an endothelial cell within the tumor, and the albumin adjacent to it with the cargo inside of the albumin. That is then released inside of the tumor. Our strategy is to activate stress response in cancers by using radiation. So when you treat a cancer with radiation, you activate many different stress responses that include things like heat shock protein, glucose reactive proteins. These are proteins that move to the surface of the cell. Our laboratory discovers those proteins, and then we develop nanoparticles and antibodies that bind to them. So that's shown here in this schematic. This shows the microvessel within a tumor. These are viruses or nanoparticles that then bind to these inducible stress proteins. Then in the cell, in the endothelial cell, we see the nanoparticle extravasate. It is transported across the endothelial cell. The drug is then released on the abluminal surface next to the cancer. This is one of our publications from Nature Medicine, where we looked at a variety of different cancers using nanoparticles that are targeted to these radiation-inducible antigens. This one in particular is called tax-interacting protein 1. When you treat a cancer with radiation, you get expression of these stress proteins. You then can target a nanoparticle to the inducible stress proteins. So here we have 4 different human cancers in nude mice. So this is a glioblastoma, a lung cancer, a colon carcinoma, and a prostate cancer. We then label the nanoparticles and image the biodistribution over time. And what we find is that we are able to localize the nanoparticles just to the cancer that's treated with radiation without delivery of the drug to other tissues.